I need you please to pause the video every time before seeing the answer key, and try to solve it by your own self. Okay? So first question and second question is direct application. So what is power? Power is defined as the rate at which work is done. And how many possible units do we have for work? We know two possible units. We know the joules per second, and this is equal to 1 watts. Jumping to some math skills, we have a hairdryer that uses 72,000 joules in 60 seconds. We need to find the power. This is the work, that's the time, and we need to find P. So power is equal to the work divided by the time. So it's 72,000 joules over 60 seconds, and this will give you 1,200 joules per second, or you can say 1,200 watts. I'm gonna use watts, okay, in the questions. Okay, fourth question, how much power does it take to push a box with 30 Newton 10 meter west in 5 seconds? So we also need the power here. So I'm gonna start by stating the power formula. But you can see that we do have the time, but we don't have the work done. However, we have the distance and the force given. So we can say that since work is equal to force multiplied by the distance, so we can say that it's 30 into 10 upon 5, and so the answer for the question is 60 watts. So now we use the second triangle in order to get the power. Fifth question, how much power does it take to lift 30 kg 5 meter high in 7 seconds? Again, we need the power, so I'm gonna state the formula, work upon time. And let's check what we have and what we need to get. We do have the time, we have a distance, and we have mass. So it's true that we know that work is force multiplied by distance, and we keep the time as it is, but we don't have the force here. But we need to pay attention over the fact that the boy or whatever, like who's doing the work, is lifting. And we know that in order to lift something, we need to exert an equal force, a force that is equal to the weight, but in the opposite direction. And so since the mass here is equal to 30 kg, so the force of weight is equal to 300 Newton, and so this is the force needed in order to lift the object upwards. So it's gonna be 300 multiplied by 5 upon 7, and this will give you around 214 watts. Now in question 6, we have a toy car's engine has 4,000 watts, so that's the power. That pulls the car with a force of 500 Newton. We know that there's a force of friction of magnitude 120 that is acting on the car as it goes on a rough surface. Find the velocity of the car. So now we're gonna use the second formula, of power. We're gonna say that power is equal to the force multiplied by the velocity. Okay, but since here we need the velocity, so I'm gonna take V equals to P over F. Okay, now we have the power, it's 4,000, but we have two forces. So if this is the car, and the car is going with 500 Newton, but there's a friction force acting on it of magnitude 120. Magnitude 120, but we know that it should act in the opposite direction since it's friction. And so the net force acting on the car is going to be equal to 500 minus 120, and that's 380 Newton. Okay, and so we will have 4,000 upon 380, that's around 10.5 meter per second. Okay, now 7th question. We have two physics students are in a weightlifting room. Will lifts the 50 kg over his head 10 times in 1 minute, and Ben lifts the same 50 kilogram over his head 10 times as well, but in 10 seconds. Which student does the most work and which student delivers the most power? Without doing any calculation, we can see that it's the same mass that is lifted in different amount of time. So what we know is that if two students are lifting the same amount of mass, and so they're exerting the same force upward and the same distance above their head, so we can say that, let me remove this, we can say that they are both doing the same amount of work. But since Will could finish in 60 seconds, 1 minute is 60 seconds, and Ben took only 10 seconds, so we can state that Ben is more powerful. Okay, that's because we know that P is the work over the time, and so if I fixed the work, we can see how P, power, and time are inversely proportional. So the less the time taken in completing the work, the more the amount of power in watts.